Assalamualaikum student. Today we discuss that is mutual induction. To discuss the topic of mutual induction, we take the two coil A and coil B. If we increase the current in this coil, here we increasing current in coil A. This increasing current due to this coil, they create the on magnetic field. The coil A which produce the on magnetic field. This magnetic field link with this coil. When this magnetic field link with this coil, they produce and induce EMF in the coil B. We call the coil A, let's say this is the primary coil and this is the secondary coil. So here we write if two coils, primary and secondary, are placed near to each other, then increasing current in one coil will induce EMF in other coil. Here I take the again two coil. Here we show the current is increased. Here in this coil we show the current is decreased. So here is decreasing current. This is the coil A which is called primary coil, and this is the coil B which is called secondary coil. When we decrease the current in this coil, they produce a magnetic field. This magnetic field also linked with this secondary coil. They produce and induce EMF in this coil. So what we learn here, whether we increase the current, they also induce EMF. Whether we decrease the current, they also induce EMF. So here we write if two coils are placed near to each other, the decreasing current in one coil will induce EMF in other coil. For explain the phenomena of mutual induction, here I take the two coils, coil A and coil B. Let's say this is the coil A and this is the coil B. Coil A, which is we call here, this is coil A. Coil A in which the current is produced is called the primary coil. Here the coil B in which an EMF is induced is called secondary coil. So when we change the current in one coil A, this is called primary coil. This produce and induce EMF in this coil. This induced EMF, this is represented by E. So here we explain the statement of the mutual induction. What is the statement of mutual induction? When changing current, increase or decrease in one coil, induce an EMF in other coil. This phenomena is called mutual induction. From Faraday law of electromagnetic induction, the EMF induced in secondary coil is proportional to the rate of change of magnetic flux. Here we discuss the important case in mutual induction. If we use the DC source instead of alternating source, the EMF is produced in this coil that is not changed. That is produce the constant magnetic field that is not changing with time. If magnetic field is not changing with time that it does not produce the induced EMF in the secondary coil. Here is no EMF is produced if we use here the using a DC source produce a constant magnetic field that is produce no EMF. Although magnetic field from primary coil insulated with the secondary coil insulated sorry there was no rate of change of magnetic flux linkage. This is because the magnetic field are constant, so no EMF induced. Here we discuss the other case in mutual induction. In mutual induction, when we using an alternating current source, when we use an alternating current source in primary coil that produce an EMF that they are changing with time, changing magnetic field. This changing magnetic field produce this EMF in the secondary coil. So here we write so alternating current in the primary coil produce an alternating magnetic field this alternating magnetic field interact with the secondary coil, so there was a rate of change of magnetic flux linkage, hence EMF induced.